In section 1.3, we're going to talk about something called factoring. So what factoring is it's sort of we're doing the distributive law but backwards. So just an easy example, say if we had something like 2x times x minus 3. We can FOIL this out or use the, distribute the 2x throughout here. So the 2x goes to the x, the 2x goes to the minus 3, so we get 2x times x, which is 2x squared. 2x times minus 3 is minus 6x. And so what this whole process was, moving from this side to this side, this is just, distributing. But we can also go from this side back into this form over here. And then moving in this direction, this is going to be factoring. So how we can move from this side over to this side. So factoring, there's going to be several ways that we can be able to do this. And it depends on the scenario, like the problem that we're given. So the first thing that we're always going to look for when we're factoring is, can we take out a common term? So take out common terms. So what that means is if we look at this problem right here, say we want to factor the right-hand side and turn it into the left-hand side. Well, something that is common between both of these, both of these we could take a 2 out from. We could take a 2 out from this 2, and we could take a 2 out from the 6. This one has 2 x's, this one has 1 x, so we could take out 1 x in total. There's at least 1 x in each of these things to take out. So we could take out a 2 and an x. If we take out a 2 and an x from this first term, this 2 goes away, so we don't write a 2 there anymore. And there were 2 x's, but we're removing one of them, so now there's only 1 x left. So when we take out the 2x from this first term, we're just left with an x. If we take out a 2x from the second term, if we take a 2 out from a 6, we're left with a 3. And we're taking out this x, so we don't write the x anymore. So that's how we would factor this right-hand side into this left. We see that we could take out a 2x, and then we write what's left inside these parentheses. So this is the most basic form of factoring, and this would just be taking out the common terms. And so the next step for now is going to be something called the AC method. And the AC method has to deal with when we're factoring things like this, ax squared plus bx plus c. And there's 2 ways to do this. So there's going to be a version when there's a number here, like an a, and also a situation when we have where this a is equal to 1. So in general, this is always going to work. But first we're going to talk about what happens if this a is a 1. So when we want to factor something like this, x squared plus bx plus c. So when there's a 1 in front of the x squared, the first step always is just to write 2 sets of parentheses, and we put an x here and we put an x here. And now what we're going to want to do is we want to find 2 numbers. So we'll call them, one of them u and the other one v. And these 2 numbers have to have a certain property. So if we multiply them together, so u times v, this has to equal this last number c. And if we add them up, plus sign in the middle. So if we do u plus v, this has to equal this middle number b. So again, whenever we have just a 1 in front of the x squared, this is always the step. The first thing you do is just write 2 sets of parentheses. We put an x here and an x here, and now we're trying to look for these numbers u and v that have these 2 properties. We multiply them together, we get this last one, we add them together, and we get the middle one. So let's see that with an example. Say if we want to factor, let's do x squared plus 7x plus 12. And we want to factor this. So first we look, the steps are always the same thing, take out common terms. If we look at this entire thing, there's nothing common to take out. So this has 2 x's, this has 1 x, that doesn't have an x. So an x isn't in common. And there's no numbers in common in between any of these things. So like this step up here where we're able to take out a 2x, that step doesn't apply anymore right now. So then we move on to the next step, which is the last step, is just use the AC method. And so right now we're only talking about the AC method when the number in front of the x, this a, is a 1. And we said when that happens, we do this step. The first thing we're going to do is just write 2 sets of parentheses. An x goes here and an x goes here. That's always the first step. And now we want to find these two numbers u and v. So the numbers that go here and here, so here and here, it says they need to multiply up to c. So c is the last number. So these numbers need to multiply up to this number 12. So here's 12. Let's write what are all the numbers that multiply up to it. So there's 1 and 12. We have 2 and 6, and the list keeps going on and on. But something we also need is that not only do they need to multiply up to 12, they have to add up to this middle number, 7. That's what this says. So they have to multiply up to c, which is this number, and they need to add up to the middle number, which is b. So if we did 1 plus 12, we add those together, that's 13. So 13 is not this middle number, so that one's not good. If we add up these two numbers, so 2 times 6, that's 12, but if we add these up, that's just 8. And 8's not the middle number, so that pair is not going to work. Let's do, how about 3 and 4? So 3 times 4 is 12. If we add these up, we get 7. And 7 is the middle number, so this one's good. So the numbers that we want to choose that add up to c, which is 12. So 3 times 4, that's 12. And then you need to add up to the middle number, so 3 plus 4 is also 7. So then this is, in our situation, our u could be 3, and our v is 4. So then we just put those two numbers here and here. So we're going to put a plus 3 and a plus 4. And then that's it. We're done factoring this. So these two numbers, the 3 and the 4, you multiply them together. That's what this says. And we get this number. 3 times 4 is 12. We add them together. We get this middle number. 3 plus 4 is 7. So this piece factors into this. So what this means is if we FOILed this out, so if we did x times x, x times 4, 3 times x, 3 times 4, we would get this piece, 7x squared plus 7x plus 12. But if we're just asked to factor, this is going to be our answer. Okay, so that's how we would do an example when there's a 1 in front of the x squared. So now let's do an example where there's not a 1 in front of the x squared. So now let's factor, Okay, so now let's factor 2x squared plus x minus 3. So if you see now the number in front of the x squared is a 2, so it's not a 1, so it's a little bit different than the previous problem. So this one's of this form, ax squared plus bx plus c. And now the number in front of the x squared is a 2, so not a 1. And so now how we do this one is going to be a little bit different. So what we need to do, in general, we take the number in front of the x squared and the last number and multiply them together. So we need to find a times c. And then what we need to do is we need to find two numbers. So we'll call them u and v. And again, so now these numbers need to have two properties. So if we did u times v, that has to equal a times c. So this number up here. And again, if we add them together, it needs to equal this middle number, b. Okay, so that's going to be the first step. So here, our a is 2, and our c is minus 3. So we're going to take those two numbers, 2 times minus 3, which equals minus 6. So now we want, what are all the numbers that multiply up to minus 6, but then they also need to add up to b, so this middle number. So what are the numbers that multiply up to minus 6? Well, we could choose 1 and minus 6. We could do 6 and minus 1. We can do 3 and minus 2, and so on. But remember, they need to add up to the middle number in addition to multiplying up to a times c. So we need the numbers that multiply up to this. So these all work, but they have to add up to this middle number, which is 1. If we add 1 and minus 6, we get minus 5. So that one's not going to work. If we add 6 and minus 1, we get positive 5. But again, we need a 1, so that one's not going to work. If we do 3 plus minus 2, we do get positive 1. So this one is going to work. So these are the two numbers right here that we need. We multiply them together, we get minus 6. And then when we add them together, we get our b, which is our middle number, which in this case is 1. So when we add these together, 3 plus minus 2, we get 1. So now what we're going to do with these two numbers is we're going to rewrite this problem like this. 2x squared. And instead of writing a plus x, we're going to do a plus 3x minus 2x. and then minus 3. And this can be in any order. Instead of having a 3 and a minus 2, we could put our minus 2 here and our positive 3 here. That doesn't matter. But so all we're doing here, instead of writing an x, we're doing 3x minus 2x. But if you notice this piece right here, that is just x. So the problem's still the same. Instead of just writing x, we wrote 3x minus 2x. And now what we're going to do is you group the, so we're going to want to like group these two together and these two together and just factor out from these two pieces separately. So we're going to just only take out common terms from the first two and then common terms from the last two. From this first two, you see that we could take out an x because there's two x's here and one x here. And that's the only thing we can take out. So we're going to take out our x. And if we take out an x from this first term, we're left with 2x. If we take out an x from this term, we're just left with a plus 3. So now in this one, what we could take out, we can take out this minus sign. So we're going to take out our minus sign. And if we take out a minus sign, we're left with a positive 2x. And if we take out a minus sign here, we're left with a positive 3. So now if you notice, if we multiply this x back through, x times 2x, that's 2x squared. X times 3, that's 3x. Minus times 2x is a minus 2x. Minus times 3 is a minus 3. So everything's good so far, nothing's changed. But now what we can do, we notice that we can factor again. We see that this term has a 2x plus 3. This term over here also has a 2x plus 3. So we can factor out the 2x plus 3. So this 2x plus 3 is just one piece. This piece over here has it, and this piece right here has it. So if we take out the 2x plus 3 from this first term, all we're left with is this one x. So we have an x here. If we take out the 2x plus 3 from this term, we're just left with this minus. So technically there's like a 1 here, since 1 times this is just itself. So if we take out the 2x plus 3, we're just left with this minus 1. Okay, and now we're done. So we factored our original piece, 2x squared plus x minus 3, into this, 2x plus 3 times x minus 1. Okay, let's do some more examples. So let's factor 2x squared plus 6x plus 2. Oh, sorry, no, let's make this a, here, 1 second. We want to do a 4. So 2x squared plus 6x plus 4. So the first step is always to see if we can take out a common term. So we could take out a 2 from each of these pieces. We could take a 2 out from this 2, a 2 out from the 6, and then a 2 out from this 4. So the first thing we're going to do, let's take out the 2. If we take out a 2, we're just left with an x squared here, a 3x here, and we take out a 2 from this 4, we're left with a 2 here. So if we multiply this 2 back across, 2 times x squared, that's 2x squared. 2 times 3x, that's 6x. And 2 times 2, that's 4. So now we want to see, can we factor this piece? Because now we notice that we have something that looks like what our one of our previous examples. Something of the form x squared plus bx plus c. That's what this looks like. So we have our x squared plus some bx plus a c. So here our b is 3 and then our c is 2. And we said when we want to factor this, the first step we always do, so let's rewrite this 2. We write 2 sets of parentheses, and we'll always put an x here and an x here. So this is the case when always the number in front of x squared is 1. And the second step was we need to find numbers that multiply up to this last number and add up to the middle number. So the numbers that multiply up to 2, we just have one option here. Or there's 2 options, 1 and 2, and minus 1 and minus 2. But they need to add up to this middle number. So this one doesn't. This plus that's minus 3. We need a plus 3, so this one doesn't work. But this plus this is 3. And this plus the times this is 2. So the numbers we're going to put here is a plus 1 and a plus 2. Again, because 1 times 2 is 2, and 1 plus 2 is 3. So now we factor this piece into this right here. Okay, let's do one more example before we move on to something else. So let's factor 6x squared plus 5x plus 1. All right, so the first thing we want to do, just like always, is see can we take out a common term. And in this one, there is no common term to take out. We can't take any of these numbers out. There's a 6, 5, and a 1. Nothing's common. This has an x, this has an x, but this one doesn't. So now we just need to move on to the second step, which is use the AC method. And now in this situation, we're in this form, ax squared plus bx plus c. So there's not a 1, there's a number in front of our x squared term now. So we can't just start like in the previous problem where we write two sets of parentheses and an x and an x. So when we remember, when we have something like this, we need to do a times c. And then we have to find those two numbers u and v, so that u times v is equal to this last number, or sorry, is equal to a times c. And then when we add them up, we get this middle number b. So in this problem, our a is 6 and our c is 1. So our a is just 6 times 1, that's 6. So we need to find the numbers that multiply up to 6, but then add up to our middle number, which is 5. So, we have 1 and 6, 2 and 3, and so on. So 1 times 6, that's 6, but 1 plus 6 is not 5. 1 plus 6 is 7. So this one doesn't work. But this one's going to work. 2 times 3, that's 6, and 2 plus 3 is 5. Okay? So we take these two numbers, and instead of writing a 5x, we're going to write a 2x plus a 3x. So we'll have 6x squared plus 2x plus 3x plus 1. And again, so this piece right here, that's just 5x. We wrote 5x instead as 2x and 3x. And then just like before, we're going to group these first two together and group these second two together and then factor out just from those two. So from these first two, we could take out a 2 and then also an x. So if we take out a 2 from the 6, we have a 3. If we take out one of these x's, there's going to be 1 left over. And now if we take out both this 2 and the x, there's just going to be a 1 left over here. And the reason for that is when we multiply this 2x back through, we need to get this piece. So 2x times 3x, that's 6x squared. And then 2x times 1, that's 2x. And then from this piece right here, there's nothing we can factor out. So we'll just put it in parentheses, 3x plus 1. Now, just like before, we have another common term. This 3x plus 1 is here, and this 3x plus 1 is here. So that's common. So we could take out the 3x plus 1. And then if we take out the 3x plus 1 from this first term, we're just left with this, the 2x. And again, we can think of there being a 1 here. So if we take out this 3x plus 1, we're just left with the 1. And then this is what this would factor into. 3x plus 1, 2x plus 1. So the last example from this section, which is kind of something we've been doing, which is called group factoring. So we use group factoring when we did the AC method. And we're also going to use group factoring when we factor, say, a problem that looks like this. So before we were only factoring things that look like this, ax squared plus bx plus c. But here we have an x to the 3 term, so this isn't of this form. So when we're have any problem that looks like this, it goes x to the 3, x to the 2, x, and then nothing. Just kind of like with the AC method, we're going to group these first two together and then group these second two together and see if we could factor anything out. So if we factor something out from this first two, well, there's a 6 and a 2, so we could take a 2 out. This one has 3 x's, this one has 2 x's, so we could take 2 of the x's out. And then left out of this one, there's going to be a 3 and an x. Since we take a 2 out from the 6, we have a 3. Take 2 of these x's out, we only have 1 x left over. And here we're taking both the 2 and the x squared out, so we're just going to have a minus 1 here. So you see if we multiply back through, 2x squared times 3x, that's 6x cubed. 2x squared times minus 1, that's minus 2x squared. And then out of this, the second term, let's just factor out a minus sign. If we take the minus out of this 3x, we're going to get a positive 3x. And if we take a minus out of a positive 1, we're going to get a minus 1. So if we multiply this minus through, minus times 3x, that's minus 3x. And minus times minus 1, that's plus 1. And now we're at this part, so you see we have a 3x minus 1 here, and also a 3x minus 1 here. So we could factor that out. And if we take out the 3x minus 1 from this first bit, we just have a 2x squared. And again, we can think of there being a 1 right here. So if we take out this 3x minus 1, we're just left with this minus 1. And this would be the answer once we're done factoring.